So our last example here with literal equations, we have a do z. S equals 2 pi, yes, that's the same pi you know from your circle, 3.14, that goes on forever. But we're going to keep it using the symbol here, 2 pi zx plus 6 pi z squared. And we want to solve for the variable x. So this is downright a complete and utter mess. But the overall idea doesn't change. We're going to have a bunch of a mess, but our goal is still just to get x by itself. So we take whatever doesn't have an x with it, that would be this stuff right here, right? Our 6 pi z squared, that doesn't have an x with it, and we need to move that to the other side of the equation. So we subtract that, 6 pi minus 6 pi z squared from both sides. And then s and 6 pi z squared, none of those things are like terms. So that just stays as s minus 6 pi z squared. And then on the other side we have a mess. 2 pi zx. We still want to get x by itself. Right? We're still focusing on the x there. We want it to be by itself. So here, all of those things are written beside x, so they're being multiplied with the x. So we have to divide by all of them. The 2, the pi, and the z. And because this is an equation, we need to do the same thing to both sides. The other side gets divided by 2 pi z. Now this just looks downright awful. S minus 6 pi z squared over 2 pi z. Really careful, you can't cross out the pi's or the z's because the stuff up on top here is being added. So we just leave it as that awful looking mess, and x is by itself. X is by itself, and there's a big old mess on the other side. But we've accomplished our goal, which was getting s by itself. And so this is by far and away the most complicated of the examples, not only because we had all the extra variables, we had the pi's running around, and so this is how we handle it. We still just want to get it by itself. We still just want to get the variable by itself, and that's how we solve these types of equations.